Our solar system is a bustling place, teeming with celestial objects of all shapes and sizes. From the smallest particles of cosmic dust to the largest gas giants, the variety is truly astounding. Each object has its own unique story and place in the grand tapestry of our solar system. Among these myriad objects are asteroids, which are essentially rocky remnants from the solar system's formation over 4.5 billion years ago. These ancient space rocks offer invaluable clues about the early solar system and the processes that shaped it. Most of these asteroids reside in the asteroid belt between Mars and Jupiter, a vast region filled with countless rocky bodies. However, not all asteroids stay confined to this belt. Some stray closer to Earth, occasionally posing a threat to our planet. These near-Earth objects, or NEOs, are of particular interest to scientists and astronomers. One such asteroid that has recently captured the attention of scientists worldwide is 2024 YR4. This intriguing space rock has become a focal point of study and concern. First detected in late 2024, this asteroid has been steadily moving closer to Earth. Its discovery has sparked a flurry of activity among the scientific community, as researchers work tirelessly to understand its characteristics and trajectory. While its exact trajectory remains uncertain, preliminary calculations suggest a potential impact scenario within the next decade. This has led to intense efforts to refine these calculations and determine the likelihood of an impact. The possibility, however remote, underscores the ever-present danger posed by near-Earth objects, NEOs, like 2024 YR4. These celestial bodies remind us of the dynamic and sometimes perilous nature of our solar system. The world watches with bated breath as scientists scramble to gather more data and refine their predictions. International collaboration is key, as observatories and space agencies around the globe contribute their expertise and resources to monitor 2024 YR4. The stakes are high, the clock is ticking, and the fate of humanity may very well hinge on our understanding of this celestial intruder. As we continue to study 2024 YR4, we are reminded of the importance of space research and the need for preparedness in the face of cosmic threats. The story of 2024 YR4 is a testament to human curiosity, ingenuity, and the relentless pursuit of knowledge in the vast expanse of space. The size of an asteroid is a crucial factor in determining its potential impact. The larger the asteroid, the more catastrophic the consequences can be upon collision with Earth. In the case of 2024 YR4, early estimates place its diameter somewhere between 100 and 200 meters. This range is significant because it means the asteroid is large enough to cause considerable damage if it were to impact our planet. This makes it significantly larger than the Chelyabinsk meteor that exploded over Russia in 2013, injuring over 1,500 people. The Chelyabinsk event serves as a stark reminder of the potential danger posed by even relatively small space objects. An impact from an object the size of 2024 YR4 could have devastating consequences. The force of such an impact would be immense, capable of causing widespread destruction over a large area. The energy released upon impact would be equivalent to hundreds of atomic bombs, resulting in widespread destruction and potential loss of life. The sheer power of this energy release could flatten buildings, ignite fires, and create shockwaves felt for miles. The exact extent of the damage would depend on several factors, including the asteroid's composition, speed, and angle of entry. A denser asteroid would release more energy upon impact, while a faster-moving asteroid would strike with greater force. Even a relatively small asteroid like 2024 YR4 could cause regional devastation, warns Dr. Eleanor Francis, a leading expert on asteroid impact hazards. She emphasizes that the potential for destruction is not solely dependent on size, but also on the specific conditions of the impact. The energy released would be immense, with the potential to trigger earthquakes, tsunamis, and wildfires. These secondary effects could compound the initial damage, leading to a cascading series of disasters that would be challenging to manage and mitigate. Preparing for such an event involves international cooperation and advanced planning. Emergency response teams would need to be ready to act swiftly to minimize the impact on human life and infrastructure. Community rebuilding efforts would be essential in the aftermath of such a catastrophic event. Scientists are actively working on asteroid deflection technologies and space missions to monitor and potentially alter the course of hazardous asteroids. These efforts are crucial in preventing future impacts and protecting our planet from the destructive potential of space objects like 2024 YR4. While the threat of asteroid impacts is real, advancements in technology and international collaboration offer hope. By continuing to study and prepare for these cosmic threats, we can safeguard our future and ensure the safety of generations to come. Earth bears the scars of countless asteroid impacts throughout its long history. The most famous example is the Chicxulub impactor, which wiped out the dinosaurs 66 million years ago. While such catastrophic events are rare, they serve as a stark reminder of the destructive power lurking in the cosmos. More recently, the Tunguska event of 1908 flattened over 2,000 square kilometers of Siberian forest. The impact, attributed to an asteroid or comet, released energy equivalent to 1,000 Hiroshima bombs. Thankfully, the remote location minimized casualties, but it highlighted the potential for unexpected and devastating impacts. "We have been incredibly lucky in recent history," remarks Dr. Jonathan Swift, an astronomer specializing in NEO detection. But luck is not a strategy. We need to be prepared for the inevitable. Deflecting disaster, the DART mission and its implications. The threat posed by asteroids like 2024 YR4 has prompted international efforts to develop planetary defense strategies. One such effort is NASA's Double Asteroid Redirection Test, or DART mission. In 2022, DART successfully slammed a spacecraft into the asteroid Dimorphos, altering its orbit around its larger companion, Didymos. This groundbreaking mission demonstrated the feasibility of asteroid deflection using kinetic impactors. By carefully calculating the impact parameters, scientists can nudge an asteroid's trajectory over time, diverting it from a collision course with Earth. However, the success of such a mission hinges on early detection and accurate trajectory prediction. DART was a major step forward in planetary defense, explains Dr. Emily Carter, a DART mission scientist. It proved that we have the technology to deflect asteroids, but we need sufficient warning time to be effective. A shattered solution? The risks of fragmentation. While deflecting an asteroid seems like the ideal solution, it comes with its own set of challenges and risks. Scientists around the world are tirelessly working on models and simulations to understand the best ways to prevent a catastrophic impact. However, the complexity of space and the unpredictable nature of asteroids make this a daunting task. One major concern is the potential for fragmentation. When an asteroid is targeted for deflection, the force applied could cause it to break apart rather than change its course. Instead of deflecting the entire asteroid, a kinetic impactor could shatter it into smaller pieces. This fragmentation could lead to a scenario where multiple smaller asteroids are now on a collision course with Earth. While this might appear less threatening at first glance, it could actually worsen the situation. The smaller fragments now scattered in space could be harder to track and predict. Depending on the size and distribution of the fragments, the Earth could end up being bombarded by a shower of space rocks instead of a single impactor. This meteor shower could cause widespread damage over a larger area. This could widen the area of devastation and make mitigation efforts even more challenging. Emergency response teams would have to deal with multiple impact sites, stretching resources thin and complicating rescue and recovery operations. Furthermore, some fragments could remain on a collision course with Earth, posing a long-term threat. These fragments could continue to orbit the Earth, creating a persistent danger that requires ongoing monitoring and potential future interventions. Fragmentation is a double-edged sword, cautions Dr. David Chen, an expert in asteroid mitigation strategies. While breaking up an asteroid might seem like a way to reduce the immediate threat, it could inadvertently create a more complex and dangerous scenario. The paths of the fragmented pieces can be highly unpredictable, making it difficult to determine where and when they might strike. This unpredictability adds another layer of complexity to the already challenging task of asteroid deflection. Scientists are continuously refining their models and strategies to account for these risks. They are exploring alternative methods, such as using gravity tractors or nuclear devices, to alter an asteroid's course without causing fragmentation. Each method comes with its own set of challenges and potential risks, but the goal remains the same: to protect our planet from the devastating impact of an asteroid collision. As we continue to explore and understand the cosmos, the importance of developing effective asteroid deflection strategies cannot be overstated. The risks of fragmentation highlight the need for careful planning and innovative solutions to ensure the safety of our planet. The future of our planet may very well depend on the decisions we make today in the realm of asteroid deflection and space exploration. Mapping the danger zones, potential impact sites of 2024 YR4. As scientists continue to track 2024 YR4's trajectory, they are also working to identify potential impact locations. Due to the uncertainties involved, it's impossible to pinpoint an exact impact site at this stage. However, based on the asteroid's orbital parameters, scientists have identified several regions across the globe that are statistically more likely to be affected. These regions, often referred to as risk corridors, span multiple continents and include densely populated areas as well as vast stretches of ocean. The exact location of impact, if it were to occur, would depend on a complex interplay of gravitational forces and the asteroid's rotation. It's like throwing a dart at a spinning globe, explains Dr. Sarah Ramirez, an astrophysicist specializing in orbital dynamics. There are many